Hello guys, and in this video I'm going to show you some more trig substitutions. These are more advanced ones. Okay, so if you encounter an integral where it is the root of a squared minus b squared times x squared, where b and a are just constants, then you want to make the substitution that bx is equal to a sine theta. Similarly, if you take in the integral of a squared plus b squared x squared dx, where b and a are again constants, you want to make the substitution bx is equal to a tan theta. And then you just integrate from there on. So let's look at some examples. These will incorporate the integrals methods that I showed previously. Okay, so this one fits the first description because a is just 3, b is 1, and the x squared is there. So let's rewrite it so it's actually, you know what, let's get straight to the substitution. So our b is 1, so x is equal to 3 sine theta. Let's integrate. dx will equal to 3 cos theta d theta, right? So now let's make the substitution. As you can see, I don't really have dx there, so I'm just going to have to plug it in as is. But you'll see how everything cancels out nicely. And sine squared theta over x squared times 3 cos theta d theta. Now remember, sine squared plus cos squared is equal to 1. So now we have, basically, we can factor out the 9 there, and we have a root 9 times a root 1 minus sine theta squared, right? Which is just equal to cos squared, right? Move this over, you get cos squared is equal to 1 minus sine squared. I wrote these identities here so that we can use them later. So I'm going to move this under. Actually, I'll move this up so it's easier. Right, okay. So now what do we do? Well, so let's replace that with cos. Root 9, let's make this 3. There's no point. Actually, keep it 9 because we have another 3 outside. So we'll multiply that in for x squared. Oh, sorry. You're supposed to, there's no more x squared here. This is just going to be 9 sine squared theta. 9 sine squared theta and 9 sine squared theta. So the 9's cancel out. So now we have cos on the top, right? So this was cos squared x, but then it's rooted, so just cancels out to cos, right? Cos theta times another cos theta d theta, right? And cos over sine is cotangent, no? So that's just going to be equal to the integral cotangent theta squared d theta, right? And so cotangent is equal to what? So we don't really know an integral for cotangent squared, but we do know one for cosecant squared, right? So if sine squared plus cos squared is equal to 1, we got to get cotangent, which is cos over sine. So divide everything by sine, you get 1 plus cotangent squared is equal to cosecant squared, right? So now let's isolate for that. So you're going to get cosecant squared x minus 1. So let's do that. So this integral will be equal to cosecant squared theta minus 1 d theta, right? So let's integrate this. As we know this identity here, integral of cosecant squared is just equal to negative cotangent theta, right? Minus 1 in terms of theta is just going to be minus theta. But the question was given to us in terms of x, so we have to put the answer in terms of x, right? But we know cotangent is just adjacent over the opposite side, right? So let's make a triangle. That is not what I drew. There we go. Okay, so we had our substitution was x is equal to 3 sine theta. So x over 3 is equal to sine theta. And sine is opposite over hypotenuse. So hypotenuse is 3. Say this is theta. This is going to be x. Oh, sorry. Yeah, 3, right? So if you wanted this side length, right, what would it be? It would be, so if this is C, this is A, this is B, it would be C squared is equal to A squared plus B squared, right? We don't know B, we know C. So we have 9 is equal to x squared plus b squared. So 9 minus x squared rooted is equal to b. And you see, that's what we had in the beginning right here. So that's how you know you did it right. Right? So let's take advantage of that. Cotangent is what? Cotangent is adjacent over opposite, right? So it's going to be, adjacent is b, 9 minus x squared, and opposite is x over x. Now we need theta, right? But we had x over 3 is equal to sine theta. So it's just going to be sine inverse of x over 3 is equal to theta minus sine inverse of x over 3 plus c. That's our answer. Okay. Let's do the next question. The next one is a little bit trickier. Okay. So this one fits the second one. A squared plus b squared x, right? A is 3, b is 2, and we have the x squared, so we gotta use tan. All right. So our x, or our 2x, will equal to 3 tan theta, right? Yep. So let's take the derivative. 2dx equal to 3 secant squared theta d theta. Okay, so x is that, so it's going to be 2x, sorry, not 2x, it's going to be 3 tan theta over 2 cubed over 2 times, well, we can just plug it in. Yeah, we can just plug it in, so it'll be 3 tan theta squared plus 9 to the 3 over 2. Let's change the integration constant. 3 secant squared theta d theta. Right, okay, now we got some simplifying to do. So let's do that separately. So on the top, we have, so 3 squared, 3 times 3 times 3, so 27. Tan theta cubed over 2 squared, 2 cubed. So 2 times 2, 4, 8, right? Over 9 tan squared theta plus 9 to the 3 over 2, right? But we can just say this is 9 to the 3 over 2 times tan squared theta plus 1. And we know sine plus cos is equal to 1. So divided by a thing is going to be 10 plus 1 is equal to secant squared theta, or x. So let's do that. Tan squared plus, so it's equal to secant squared. Let's substitute that. There's going to be 9 to the 3 over 2 times secant secant squared theta, right? But okay, let's simplify that 3 over 2. So it's going to be cubed to the root, right? So you have 3 times 2, which will give you a power of 6, divided by 2, which will give you a power of 3. So really, this, after all that simplification, is equal to this. Sorry, let me just make it easier to read. On the top, 27 over 8. Actually, let's put that outside. Let's put all the constants outside. 27 over 8 divided by 9 to the 3 over 2. Right? That's all the constants. Times the integral. 10 cubed theta over secant cubed theta, right, times 3 secant squared theta d theta, right? So this cancels out. And did I forget to bring this 3 out? I think I did, so there's another 3 here. So we'll put that there as well. Let's rewrite this. 27 times 3 over 8 times 9 to the 3 over 2 times 10 theta cubed over secant theta, right? And then we have d theta by 8 times 9 to the 1 second over 2. Okay, so let's just simplify that. It's 27 times 3, 81. 81. Okay. So now we know that tan cubed is just sine cubed theta over cos cubed theta, right? And so now we have this multiplied or divided by 1 over cos, which is going to be just times cos theta. Cancel these out, you get sine cubed theta over cos squared theta, right? So now here's the thing. Remember we learned that we could break the sign and use the identities. So this is just equal to sine squared theta times sine theta over cos squared theta. But then sine squared is equal to 1 minus cos squared, right? So if we do that, 1 minus cos squared theta over cos squared theta times sine theta, right? Now we can have a u substitution. So if we make u equal to cos theta, right, du negative sine theta d theta, right? So now knowing that, let's rewrite this nicely. 81 over 8 times 9 to the 3 over 2 integral of 1 minus cos squared theta over cos squared theta times sine theta d theta, right? So now after this, let's make that u substitution we just did. I'm just going to make this constant equal to, let's just say d is equal to 81 over 8 times 9 to the 3 over 2. I'm tired of carrying it over. So we're going to have d times 1 minus u squared over u squared, right, times negative. So it's going to be a negative d. So du. Now we can easily solve this, right? Because everything is divided by u squared. So it's just going to be negative d 1 over u squared minus 1, right? So let's integrate that now. So you have u to the negative 2. We're going to add 1, u to the negative 1. So it's going to be negative d. Actually, let's keep the d on the outside. Negative d times negative 1 over u minus u plus c. Right? Okay, so now u was equal to cos theta minus cos theta, right? And now we gotta come up with the triangle. So our original x was what? Our x, so we had 2x over 3 is equal to tan theta. Equal to tan theta. Let's say this is theta. Tan is opposite over adjacent. So this is 2x. This is 3. So this would be 9 plus 4x squared. You see? So now we have negative d, negative 1. What's cos going to be? Adjacent over hypotenuse. So 3 over, so now the thing's going to come on top. 3 over root 9 plus 4x squared minus 3 over root 9 plus 4x squared plus 6. And that's the answer. I hope this video helps, and if you guys have any confusions about it, let me know and I'll help you out. Have a good day.